Hey guys, in this episode we're focused on the intake for my Barra T 4580 build. We're going to be designing a custom airbox and then making the airbox and a custom snorkel as well. So I'm going to take you through the design process, some of the considerations I took into account, and then I'm going to run you through how I actually made this thing. The first thing that's important to note is that I am going for a custom setup. Now, I did try a few off-shelf solutions and I mocked them out of cardboard and I just couldn't get them to fit. So I just sort of decided that a custom setup was for me. If you look at the engine bay on my build, there's space on the other side to have a really nice airbox, and I probably could have fit an off-the-shelf one in something like Patrol Doctor. Yeah, I really didn't want to run the crossover pipes, and the reason I didn't want to do that is because it's quite counterintuitive. You know, you're running cool air over a hot block and then it's sort of doing the opposite of what an intercooler is supposed to do. So that's one of the reasons why I didn't want to do it. It might only be negligible. I also don't like the look of it. I really want my plumbing to be simple for the build. I guess my methodology for this build is really keep it simple, stupid. Maybe for my next build, I might try and do something a bit more extravagant. I just want something that works and is basic and is easy enough to make. Yeah, this is really the first part on the car that I'm designing from scratch, and it's a really nice, simple one to get started with. So I guess if you're doing one of these builds at home, it's good to start with simple stuff before you get onto the more complicated stuff, like my fuel system, which you'll see in a few weeks' time. Just like the rest of the build, I haven't designed an airbox before. I hadn't even really thought about designing one up until last week when I made the realization that I need a custom airbox. Let's quickly talk about the filters. I guess I've chosen a pod filter because I think it's going to be easy to seal and to work with. It's just a little bit more simple. I think the flat ones are actually probably a better filtering efficiency. I don't know that, but I have done some reading on it. So the pod one, when you think about it, I'm just going to put it onto a 4-inch tube. It's a 4-inch pod filter, and it literally just, you know, it's going to be really easy to create a seal. Like I said, just want to keep it simple. I've done some reading, and the flat ones, it's easy to get a dusted engine if you don't design them right and if it doesn't seal properly. I started in CAD with a 4-sided box, but I soon realized that the pipe from the snorkel coming in would have to be a 45-degree angle, that the 45-degree angle was going to come in on the side of the filter, and I didn't think it was going to be good for airflow. So I changed it to a 5-sided box, and the inlet is a bit closer to the front, so I think that's going to be better for airflow. The other consideration is that I've got to get a silicone joiner in there to join my snorkel, and I guess that's why I went for the 5-sided box. I couldn't just punch straight out the side of the car. I have to go out at a 45-degree angle just because of packaging space. I haven't modeled everything in CAD, i.e. the nuts and bolts and all the inlet pipes and weld beads, because I just don't think it's worth my time. I'd call this the 80-20 approach, when you get 80% of the design done in about 20% of the time, and the rest of the design, fiddly stuff, takes way more time to model, and therefore I've deemed it not worthy of my time. Let's talk about the material selection. I picked 2mm Ali. I probably could have gone a little bit thinner, maybe 1.6, maybe even thinner again. It's not a super structural part. It's really only supporting the weight of itself and the filter. So I picked 2mm Ali to do the actual box out of, and then I'm going to use 3mm flanges up the top and for the lid. I'm using 3mm for the flanges and the lid because I want it to be relatively rigid when I clamp down the gasket. Airbox size and the inlet and outlet position are really important to the performance of the engine. So I've sort of just reasoned my way through it, looking at the geometry and just imagining the airflow. I'm not going to do any CFD on this, and I'll tell you the reasons why. Ultimately, my reasoning for this is I'm using a 4-inch snorkel, a 4-inch filter, and then the turbo inlet is 3-inch. So when you think about that from a high level, I guess, you know, the turbo inlet is the limiting part of the system, so I really don't think it should be a problem. And why am I using 4-inch for snorkel and airbox? Because I think it looks way better, and I'm also future-proofing my system just in case I ever need to upgrade or change turbos. Yeah, I guess I've seen the goods and the bads of simulations. It is an extremely powerful tool if it's used right. I don't have the time to set up a simulation and do it properly and give it the attention that it needs to if I want to stick to a year-long timeline on my build. I'm very much from the build and test school of engineering. I'd have to simplify the geometry to get it to mesh right, as well as making some assumptions about boundary conditions that I really don't know. The result is only as good as its inputs, and those are the main reasons why I'm not going to use simulation or CFD especially in this build. There is scope to show you some FEA. I'm doing some tray mounts, and that's relatively easy to model, and I'm pretty confident on my model. So if you guys want to see that, let me know in the comments. The way that I did this in CAD was I modeled it just as a box at first, And then SolidWorks has this beautiful tool called sheet metal, and it literally just turns it into sheet metal, and you can choose your bend radiuses, and then it completely folds flat. And then I send it off to the laser cutter as a DXF. It comes back to me with precision that I could not achieve with an angle grinder or plasma cutter, and it doesn't take any of my time up. My mate Lawrence has generously offered his folder yet again, so wouldn't have been able to do this job without him. Done a bit of folding before, but I've always sent it out to people that know how to fold, and they critique my design, and I take those changes on board and then I fix it. But I've never had to do it using a folding machine myself, so there have been some problems with this. The 5 sides, if I did another one again using this exact folding machine, I would do it very, very differently. But that's okay, I guess it's a learning experience for me. This is a classic example of engineers cooking up shit on CAD that you actually can't make in the real world. I've had to initiate some of the bends just using the edge of the workbench and some clamps and a piece of angle iron. But yeah, I mean, I've managed to get it, and I have, you know, been using hand bends. I haven't been able to do it all on the folding machine, but that's all right. It's come up all right. There's some nice sharp edges there, so yeah, it's still salvageable. But yeah, if I did it again, I'd definitely do it another way. I'll definitely take my learnings with me when I do my fuel tanks. We've got my mate Darcy here today. Darcy is a really handy aluminium welder, probably one of the best ones I know.
Scraping the barrel.
So the idea is to weld up the airboxes. I've got to use some bolts to fasten it from the top to make it completely sealed. So I'm going to have to put some nutserts in because I won't be able to access them once it's all welded up at the top's on. So I've got a nutsert tool here. I've never used one before, so I'll give this a crack now. And we're going to be welding some 2mm alloy today. So that's definitely on the thinner side of aluminium. Honestly, I haven't really done a heap of it in the past, but I'm doing 2mm on my airbox for practice, because if you can weld 2mm, you can definitely weld 3mm. So I do have 2 airboxes. Yeah, I mean, it's a no-brainer. It was super cheap to get another one cut, and it's cheap insurance. So yeah, we can have two goes at welding them, basically. So we're using some M6 nutserts. Obviously, I don't want them protruding above the surface because I want to make as good a seal as possible when I put the rubber gasket on. To compensate for this, I put a little bit of a chamfer just using a drill, and then I'm pressing them in. So this is the first one, and you can tell it's pretty much flush with the surface, so that's perfect. The rubber gasket will go on there really nicely. I guess when I did the tolerancing, I messed up a little bit, so I'm having to use the press, which is actually probably a pretty good thing because it means the nutsert's in there nice and tight and there's no chance that that'll come out. So I'm using the press just to put them in. Normally you don't have to do that when you're using nutserts. Nutserts all in, worked beautifully. Really stoked with the way that came out. Now we can go ahead and weld the lid onto the box. First tack, hopefully I haven't welded a whole heap of 2mm before, to be honest. Hopefully I won't cock this up. That went horribly. That is horrible.
First tack, definitely not take 2. First try.
We're using this super sophisticated welding clamp ratchet strap. As you can see here, you can buy these online. I think general purpose tie down is what they come under.
All your good welding stores should sell them, yeah?
Yeah, all the good welding stores will sell them. Obviously, it's really important to get this top flange completely flat. Now, I don't have a weld table, so my plan is to use the lid as a brace to keep it straight. I'm going to use bolts and washers, and yeah, hopefully that'll keep it flat. Obviously, there is a gasket going in here, so we've clamped the lid and the additional flange that I have for my other airbox. So we've got 6mm that we've clamped onto, so hopefully this will keep it flat enough. We're just going to tack it up first, and then we'll do some full passes. There have been some limitations with my folding. I sort of already explained that. but we have to fill this gap, which isn't the easiest thing out of alley, let's be real. Might grab 2 or 3 filler rods simultaneously and just jam them in, but let's go for it, eh? How's that Serenity, Das?
Pretty serene.
Some of the best dialogue I've ever got on camera. Finished up with Darcy. I'm just showing you some of the better welds. We managed to dial in the settings together. Like I said, I'm not an expert on alley, and Darcy hasn't welded in a while, but he's definitely got some fine motor skills. So yeah, I guess I'm going to clean up the stuff that I'm not happy with. Something that was pretty evident during the welding process was this table is not good enough. I just found it in the hard rubbish. Like, it's just super uncomfortable. When you're standing, you can't use it, and when you're sitting, you can't really use it. So yeah, that's something I've got to sort out before I do my fuel tank. I was really hoping that I could wait until after the project and do it, but with the fuel tanks coming up, I'm going to have to make a TIG table now. So it's just some extra work that I didn't encounter for. I mean, obviously you can buy them, but I think they're a rip-off personally. It'll be way cheaper to just laser cut and make it out of blue bar. So I'm going to have to do that before I make those fuel tanks. It's been a really good test and learning experience for me doing the Airbox first. It's definitely a simpler piece and a less crucial piece than the fuel tanks. I mean, if you don't have an Airbox, probably not the end of the world. You can just, you know, bang a pod filter on. It's really showing me the holes in my welding setup, so I'll go ahead and fix them before I go do anything else that's a bit more serious. The filter is in. I'm just mocking it up. Obviously, I've got to put an inlet tube on this side, and then one to my 90-degree reducer elbow to the turbo. In case you're wondering why I just don't use a bandsaw for everything, I just can't for the life of me get this one to cut straight. It is the cheapest one available on the market, and I guess you get what you pay for, and I've really tried hard to calibrate it. I actually spent probably a whole day trying to calibrate it to get it to cut straight, and it's not quite right. So it doesn't really matter for stuff like my 4-inch intake pipe, not really. But anything out of stainless, I can't fill the gaps very well. So that's why I am using these pipe guides and a saber saw as well. Just finished profiling both the intake tubes. I had to put a chamfer on this one. So you can imagine the Airbox is going to go in there. And then I've got this internal one, which I can clamp my air filter to. Now all I have to do is sort of, tack it all up. So tack this one to that one, and then I'll be able to do some full passes and weld it all up. First test fit to the car, can't be disappointed with that. Have a look, the filter's in. So I haven't welded this in yet. I'm just sort of mocking it up just to make sure and triple check before I do. I've also got to drop a bead of weld around this pipe here, so then the hose clamp on the filter has something to clamp to. I couldn't do this before I put it in the box, otherwise I wouldn't have been able to get it through this hole. I gave a lot of thought when I was designing it to actually assembling it. I've designed it around the bigger filter size, the more standard one. So I think this is the shorter one, like the 153, and then I should be able to take a 183 as well, especially with the flexiness in the silicon, which I didn't account for. It should be able to slot over there. But yeah, I mean, worst case I just run these. Otherwise I can run the more generic ones. By the way, this filter is from barratheworld.com. They hooked me up with it, so yeah, really stoked with it. It's a BMC air filter, which is quite a high quality, reputable brand. So I've made sure that I haven't welded this first. I can rotate the tube around to get that clamping bead that I'm looking for. I've already done a clamping bead on this side because I could. So yeah, just making sure this one's all free. The other thing I should have mentioned is I've got dedicated stainless steel brushes that I'm cleaning the alley with. I'm only brushing it one way. I'm being really thorough with it because otherwise you get black bits and crappy looking welds. So yeah, that's another thing that I'm doing. I have been doing that with all the pieces before I weld them. Here's my airbox out in the light. I find alley welding the hardest by far, and I really struggle to stop and start again if I can't do a full pass for whatever reason, if I can't move my hand in the right spot. If anyone's good at alley welding, I'd love to know any tips to stop and start my welds and, stop this nonsense, because, yeah, it really does wreck it. I guess I put a bit of time in and went over it and tried to fix it up as much as I can. It's definitely not my strong point, but I'm getting better, and I guess I'm really glad that I tackled this before I tackled my fuel tanks. Something like this, it's easy to, when you're welding a corner like that, I find it quite easy to do. But then as soon as you're on like a thin joint, I do struggle. So I'd like it to be neater, but it's not the worst job in the world. I've seen definitely some worse alley welds, including some from myself. So I'm happy with it overall, and definitely car worthy. I definitely improved at my welding while I did it. So yeah, really happy with the result. And I guess now we can make some mounts, and then we've got to punch out that hole for the snorkel. So I've got the airbox in the car now. I'm really happy with it. I have temporarily mounted it under here. I've just got a little tab off my radiator support and a corresponding one on the airbox. Now, I am pretty sure that my guards are going to come all the way up to the top of this panel, and I am going to be able to put another mount on this side here, but for now, this will do. This is in the right position. Let's just have a quick look at the clearances. So there's a bit of space between my master cylinder. There's a heap of space as well between the hot side of the turbo and the airbox, and then a heap of space between the manifold as well. So it's not too close to anything hot, which I'm really pleased about. So really happy with the position. And now I guess the next part of the puzzle is to cut a hole into the airbox. Quick little note on snorkel design. The idea is to punch through this panel. Now I'm doing this because I want to be able to open and shut the hood without worrying about the snorkel. So I'm going to come through this panel and then along here and then up the windscreen. Now I got this tab laser cut out, so I didn't have to do it. I got it cut a little bit longer than I thought I needed to, so I'll probably have to cut it down to size. The idea is I have an air intake there. I've got a Safari one that just goes onto a 4-inch piece of stainless. So yeah, that's pretty much the next steps. Oh, by the way, I'm going to have a joiner in between the airbox and the snorkel. So just a 4-inch silicone joiner from barratheworld.com. Remember those plasma stencils I got cut out last episode? So I've got them here. I've got my 4-inch hole, so I should be able to use it on this panel here and here as well. I've compensated for the tip of my plasma cutter. So let's have a look over here at my plasma tip. The bit where it cuts on the plasma cutter is around 3mm from the edge. So if you can imagine, when I run my plasma cutter around the circle, it's going to be 3mm in from the diameter of the circle. So I've compensated for that in my stencil, so it should work out perfectly to be a 100mm hole. Obviously you could use a hole saw to do this, but really that's no fun. I'd rather be cutting shapes than using a hole saw. Hole saws, actually, there's a bit of art to using them, in my opinion, and I just don't have the finesse, to be honest. So I'm all for plasma cutting. Now I probably will have to grind the inside because it won't give me as clean a cut as a hole saw. I have been practicing my plasma cutting, so I've been using my stencil on just a flat piece, and I guess I got my tolerancing right with my stencil, so I'm really happy that I can fit a 100mm piece of tube in, and I'm able to sort of rotate it a little bit, which is exactly what I'll need for my snorkel. Well, my practicing paid off. That's way cleaner than I expected, to be honest. So yeah, I don't have to do anything to clean that up. Maybe just run a file along the inside, and yeah, we're good to go. It's time to stop and reflect on the plasma cutter's greatness. As you can see from the time lapse, I punched 3 holes. I used my 3-inch and 4-inch circle guides. Obviously, I'm going to have to clean this up with a die grinder or an angle grinder. In case you're wondering why it's an oval, it's because the tube has to pass through on almost a 45-degree angle. Let's pull back and reveal. So this is where we have to go from this hole through here. It's going to require a bit of fabricating. And in case I haven't explained it before, why didn't I get this laser cut, you ask? Well, because I didn't exactly know where this was going to be mounted. Now, this is a hard point because the filter fits exactly in here, and I wanted it to be a certain distance from the top and a certain distance from the bottom. So this hole was a hard point, so I got that one laser cut. And then this one, I didn't exactly know where this was going to be, so I didn't want to cut it up the top, for example. I would have had to come down on an angle through here. Even if I had to cut it in the middle, then I would have come down on an angle through here. So by not cutting it and then cutting it post with a plasma cutter, it's given me the freedom to put it exactly where I want it. So I'm pretty new to the whole plasma cutting thing. I guess I saw a friend using one and I decided I needed one. So I've gone out and bought literally the cheapest one on the market. I think it was like 270 bucks. It's the Rossi Welders Cut 40. I'm pretty sure that it can only go up to 5 mil. But I don't plan on cutting anything thick with it at home. It's more just for, 3 to 5 mil tabs. So I guess it's got some really good reviews. You don't need an expensive one to get good cuts. On the side of the Landcruiser and on the Airbox, I got some really good cuts with this, so I'm pretty happy with it. So if you're thinking about a budget setup, this is a pretty good one to get, I reckon. Okay, so I've tacked in this. I've got a 4-inch silicon joiner. This is from barratheworld.com, so thanks Mez and Chris for that. And then we've got a 45 degree elbow, and it's going to run just a little bit straight and then straight up. I want my snorkel head sort of just in line with the roof. And I guess this is the most challenging part. So this angle here isn't exactly 90. So I've got to cut an angle in a 90 degree radius to get it. I haven't had much luck cutting angles dead on a 90 degree radius or any radius for that matter first time. So I've sort of got it all traced out. It is hard because it's in between sort of two hard points. I've got that tab there and then I've got that airbox there. So this is a reasonably tricky piece of fabrication. It looks simple. There's not many parts to it, but it's going to take me ages to get this right. So bear with me. Watch the time lapse of me messing around and making a heap of mistakes. So glad I really checked it. When I was doing this vertical piece here, I opened the door and it clashed with the snorkel. So what I did to compensate is just bent this tab. All I did was put a slit in the back with an angle grinder. I'll do a full pass on it eventually. And then that should get rid of my clearance issues. Okay, I've tacked it all up. So pretty happy with the position. Giving it actually a bit of thought because the cab angle, or the bottom of the cab and the top of the cab are different angles. So yeah, I didn't know what the best way to go about it was, to be honest. I didn't know which angle to match, but if you match the top, then the bottom of it sticks out really far. And if you match the bottom, then the top of it sticks out really far. So I've just sort of met in the middle. It looks like a K, I guess, if you were to actually look through it. But yeah, I think it's all good. So now is the hard part. Is to cut this bend to the correct angle. I'm trying to chase the grain as I cut. I think that will give me a circle when I'm finished, or at least I'm hoping. So I've used a rubber band and a pen. I don't know if there's a better way to do this. It's just what I'm thinking on the fly. We're all tacked up now and I'm actually really happy with it. I'm down to my last stick of filler rod and it's too late to go to the shops tonight, and I'm really glad that I've got this result because I don't think I'll have to actually use much filler at all, and I'll be able to fusion weld most of it. So all done with the welds on the snorkel, more or less pure fusion. There are a few bits that I had to use some filler rod. So now that I've done this, I can yeah, put it back on the car. The other thing that I've done is welded this flange on the airbox, so ready to go put this back on the car as well. One thing I completely forgot about was putting the extra beads on to lock the silicone joiners in with a hose clamp. So I've put my alley one on. Unfortunately, I can't do my stainless one tonight because I don't have any filler rod, and it is impossible without filler rod. So I'm going to have to do that another time, next time I get some stainless filler rod. For my custom airbox, I've got to make a custom gasket. I'm just using a 2mm piece of rubber from Clark Rubber. Just got a rubber sheet, and I'm just going to cut it out with a Stanley knife and then punch some holes in it. And I think that's going to be all right. I mean, once it's clamped down evenly, I think it should do a good job. Obviously, there's some good ways I can test this. So here's a shot of my airbox. I can't be bothered doing them all up. Like I said before, it's a 2mm rubber gasket, and I think it should be airtight and seal up nicely. The other thing that I was thinking was maybe I'll get a clear lid cut as well. So it's pretty easy for me because I've done it all in CAD. I can just send the DXF off. Although I got a quote back and it was like $100 for a 6mm Perspex lid. Let me know if you know any good laser cutters that will do Perspex for reasonable prices. I'll definitely go see them. And the reason why, I guess, because it would actually be really good to check your filter. I'm sure that it's going to get scratched up and look pretty shitty in the long run, but actually functionally, I think it would be better. Here's a shot of the complete snorkel. I probably could have made it out of a few different materials. I chose stainless because I'm really enjoying working with it at the moment. I am planning on getting it ceramic coated black. So this whole thing is going to be black. And then I've got my Ram air scoop at the top. Now, a few people have questioned why I'm using an air scoop on the top and why I'm not just, running a piece of stainless tube back like that. Number one, I guess the build is about personal preference. And on an FJ, I personally really like the old school look of an air scoop like this. And the other thing is performance. I've actually watched a few videos on, forward or backwards facing snorkels. From what I've seen, them using their empirical tests, the forward facing is way better for airflow to the airbox. Quickly, the whole intake system from top to bottom. We've got the snorkel. We've got it through the silicone joiner, so I can remove the snorkel properly, and you do need that. Then I've got the airbox, and then I've got a 90-degree reducer straight into the turbo. So it's actually quite a simple system. There's not much to it, and like I said, there's no crossover parts. Definitely, I could put an airbox here, and if I had crossed over the engine, but I don't like the look of it, and I think it's counterintuitive anyway. I'm really happy with how it turned out overall. If I did it again, I'd definitely do a few things differently. That includes the design of it and the manufacture of it. I think maybe I could make it look a little bit better and more aesthetically pleasing on the eye. But I am happy with the result overall. And I guess it's car worthy. It's going to be functional. I don't think it's going to break. As I mentioned in this episode, I'm going to have to build a weld table because I just don't have a good enough welding setup. Let me know in the comments if you want to see how I do this and why mine is better than a commercially available one and why you should pay me cash for it. No, I'm joking about the cash part. But let me know if you want to see a video on it. Otherwise, I've finished off the design for my fuel system finally, and my tanks are getting laser cut probably as we speak. That is a huge job, so bear with me for a few weeks. That could take a while.